just need to carry on, otherwise I'm running out of time here with this idea. So,
I guess
Why this is cool as malware reverse engineers, we enjoy.
God damn, I gotta log into another emulator.
Custom virtualized.
okay, so the shadow mapping idea is the the second simplest one. The first one, the first one was focusing on modeling shadows in objects, right? So the planar surface idea. So you have an object, calculate the angle from light to a surface, and then just project the object on that surface. You know, in dark color, for example. I mean, with a fixed shadow value, right? So the second one looks at the entire scene. So you basically model the scene from the depth information from the light perspective, then from user perspective, you overlay it, and in order to identify which of the visible vertices are illuminated and which ones are not. So that's one way of just figuring out whether something is in shadow or not. Nothing more than that. Yeah. Again, the shadows are hard and fast, so no continuation there. Another approach is to it's called referred to it as area subdivision, and the idea is similar to separate light from darkness by actually identifying which part of a given model are within or out of a shadow and draw them separately. And the idea is there that once you figure out whether a particular geometry is in shadow or not, you render the shadow geometry to a stencil buffer. So you kind of use or abuse this one for two purposes. Then you render the scene twice. First, you render only the shadowed parts of the entire model by inverting the test on the stencil buffer. So again, the stencil buffer keeps the shapes that are, for example, shaded, but you can then apply a test to the stencil buffer and say only draw everything that has a value smaller than 1 or everything that has a value greater than 1. So you basically iterate over it twice, only draw the shadowed parts first. Again, with your application of what a shadow means, in this case, a gray shade, for example, so not any continuation function or anything like this right now, assuming you, of course, could build it into your shader to do that. But then you iterate over the stencil buffer for a second time, and this will be all the components that are fully illuminated, so you don't need to apply any shadow functionality to it as well. So that's another approach that is used to separate shadow from illuminated parts of a model. So, but again, it doesn't solve the issue of actually identifying to what extent the shadow will, reduce the lighting on a particular object. So the other, if we move towards 3D-ish, well, 2D or 3D,
2.5D.
2.5D. One of the other approaches there to operate with a more continuous concept of shadows that also has, continuous in the sense of having granularity or granularities levels of shadows, is that yes, you basically model a volume, and I think it's best represented in that slide here, which I took from a NVIDIA presentation on that particular topic. And the idea is there you have an object, you have a light source as usual, and you just project the edges of the light source towards a particular surface, and if it's three-dimensional, you get a volume. That basically is an area that's obscured, so that area is considered shaded. And you can just apply some sort of function that reduces the light, for example, the lighting values by half or whatever else, the fixed function that you apply to it. But the neat part about this one is that it allows you to have multiple layers of shadowing. So if you use shadow volumes, you could have not only have the fact that there is you can determine whether a surface that is shaded is actually shaded or not, right, if it's exposed to light, but also having granularities. For example, if you have a light source and some sort of shadowing objects or multiple of them, you can apply factors of shadowing across the the different objects layers in practice. So and if you then model it from an eye perspective, a particular object that lies, for example, in this position here, you know that it has it's shaded by two individual objects, so you can apply a stronger level of shadowing or harsher shadowing function that you would do in an area that only in which only one object obscures your the object of observation. So that's the key idea here. So it's relatively straightforward that you just iterate through the individual volumes that are produced by those obscured objects, and then you kind of additively determine in how far the target object is obscured or not. For example, from an eye position object would be sitting here, would only be shaded by one object, so have a moderate shadow applied to it, whereas one that's situated here would have a stronger shadowing applied to it, and one that's situated here is probably hardly visible at all. So that's one simple way, again, of emulating a granularity of shadowing. So it's not just you know, shadowed or not, but actually you can apply multiple levels of shadowing. That's the concept behind the shadow volumes. So that's a bit of a richer concept as opposed to the other ones that highlighted before. And this is the idea in action here, basically. So if you have an object that sits within or outside this shaded area, you can model in how far it's actually you know, obscured. For example, an object here that's unshadowed, basically you apply all the incremental shadow additions and subtractions, and you find out, okay, this object will actually not be obscured because it's not it's no longer obscured by any sort of object that's in its path, right? So whereas again an object would be situated here, would have a would have a level 2 of shadowing, for example, right? So you have one shadowing by this object, the second level by this one, third one here, and one reduced again because the obscure this one would no longer obscure this particular object. So that would be an approximation of determining, okay, the shadow on this object will be probably on this particular point will be smaller than it would be here. So that's the principal idea, and you can do that in a three-dimensional space. Yeah, so that's the cheapest. No, it's not cheapest, but a simple way of having a more continuous or richer model of shadowing as opposed to the binary ones that we saw before, like the shadow mapping idea, which basically just identifies whether something is shaded or not. Yes, cool. What are so that's the principles referred to as Z-pass. So because you basically just passing through from you model the path through from the eye to the object of observation, and then simply calculate how many passes through different shadow boundaries you're doing, and whether they are determining the beginning or the end boundary of a particular obscuring object. So challenges in terms of lighting, in terms of shadows, involve the idea that you need to find out whether something's obviously in front or in the back. So it's one of the challenges when you have different richer objects with various faces here. The normal information is obviously quite important. Does it point into the direction of the light or not will determine whether the face is front facing or back facing. Unclosed surfaces, yeah, it's hard to identify because the only thing the thing that you need to know to calculate shadows is to find the edges, right? So if you have an unclosed surface, it's very hard for you to calculate or determine the edges. And it slows down considerably with the large number of or richer geometry, right? So with the larger number of edges, the more processing necessary, that is from a performance point of view the critical aspect. There seem to be some approaches in the area of computer vision that do that. So basically apply techniques from computer vision to determine edges as opposed to just calculating them based on a geometry. So basically just analyze the image that is rendered to, or a candidate scene that is rendered to the user, and apply some edge detector to figure out whether you know, something is actually an edge or not, and use that when extended to the projected surface to draw the silhouette. So that's the approach that's taken there. Yeah, so those are some of the principal ideas in terms of shadows. So even though we approximated the idea of, or we talked about the idea of having continuous shadow components, not only hard and soft shadows, like in the case of shadow mapping, in reality, light sources, of course, not either. Generally, you don't have a full obscured object or a fully illuminated one, but generally it's some sort of continuity along that pathway. And we differentiate between two different kind of shading. One is the umbria area, which is basically completely shaded, and the penumbria, which is kind of has soft shadow elements where we have a continuous shadowing function. And the idea is then, if we model light sources as, or if we increase the, if we create area light sources, where necessity we start getting those wedges here that are soft shadows. So they're obviously in direct correspondence to the area of the light source. And the idea is then that you need to calculate some sort of apply some sort of continuous, some sort of function to determine the extent to which this partially shaded wedge is actually obscured. So that's the idea there. So soft shadows are very expensive to calculate because the question is how complex the you know, your soft shadow functionality is basically is. So it's makes it a lot harder to have an accurate representation of a soft shadow than it is to have it for a hard shadow. So one of the way that's done is to identify different areas. So basically, you have segments within this wedge, and then interpolate the shading factor, if you like. So you basically have different incremental stages in that, or incremental areas that increase the level of shadowing, as opposed to having this complete shadow or complete illumination. So of course, the question is in how far how fine-grained those different areas are, because the more of those you define, the more you know, calculation is necessary in order to determine the partial shading. So that's one of the challenges there. Cool. So yeah, so the whole concept is actually quite straightforward, but again, it boils down to granularity, which makes it expensive. So, and yes, so the one that I alluded to was one of the one that would be used in the case of shadow mapping. If you have shadow volumes, so we have you model a three-dimensional space, you actually model it not so much from modeling the boundaries of the shaded area, so the hard shade and the illuminated area, but actually you're looking from a light perspective, and increasingly at shading components based on distance from the light source. So because you take into account the fact that lighting decays, the attenuation of light that decays over distance. That would be the other approach that's taken if you're dealing with shadow volumes, as opposed to just the simple mapping of whether an object is in front or in back of a particular other vertex. So that's the idea. Do we have this built in? No, I don't think we have any built-in functionality in OpenGL. For some shadow functionality is provided in OpenGL, but those ones, because of their performance impact, need to be implemented by hand. Yes. Cool. Yeah. So the other aspect is multiple lights. I won't go too deep into that one, but the idea is quite straightforward. Once you have an algorithm that you choose to apply, so including first of all determining whether something is shaded or not, then the extent of the shading if you want, so either using the shadow volume concept or using the any of those functionalities to determine soft shadows that are sitting at the boundaries of area lights, the penumbrian area. You basically calculate this for every light. So for every vertex in your scene, you need to apply to from all lights perspective and basically add up the shadowing effect in order to calculate those. So you can have quite realistic effects. The only impact of using multiple lights is performance, but not so much complexity. So it's not like you need a new algorithm to determine how to deal with multiple lights. Once you figured it out for one particular light source and light type area, with point light, for example, you can just apply it for all light sources in your model. So that's relatively straightforward. It's just performance, as usual, that makes it harder. So similar, this mechanism that I highlighted here with the shadow volumes that basically looks at the distance of the projecting surface from the boundary of the obscuring object is also applied if you model things like mist or fog, so that you have some sort of translucency function that limits the transmission of light, right? So the further the distance of the object from the light, the stronger the obscuring will be. So you have this kind of fog-like effect where you have a kind of a blur effect that you mentioned, that was mentioned down here. So where you actually can combine both of those, not only based on distance, but actually also you interpolate the boundaries, so you get this blur effect of losing the crisp perception of the environment. And that's used to model aspects such as mist or fog, or those water spray ideas, so that you either model the shade as a semi-transparent object itself, which is one option, or you apply a kind of some sort of function that reduces the transmit light. If you want to have the light ray effect that that is shown here, so then you would model the translucency for the particular for the particular vertices. So yeah, nothing else to add here. No, it's just the fact that it's extremely costly. That's why it's hardly used in, or it is used, but that's why it's oftentimes very sloppily used in real-time graphics. So it's good for still scene rendering, but in real-time graphics that's very expensive to use, whereas the cheapest one is obviously to provide simple planar shadows, as we discussed in the earliest case. So that's something you can quite easily do with out of the box using OpenGL. But as soon as you get into the richer concepts of having some sort of continuous shadowing concept, then it becomes more costly, such as shown here in this example. So anyway, that's pretty much all I had to say about shadowing in this case. I think Ahmed prepared a lab. You haven't seen that yet on shadows. We still need to refine that because we have a bit of a glitch there. And then you can explore that. Next week, do we have any session?
It's no. Easter break.
Easter break.
I don't think we have anything next week at all.
Ah, you don't have anything next week at all. Okay, that's a bit of a pity. Okay. Cool.
Everybody assumes there's nothing. I don't know. I don't care if there's nothing. I'm not here anyways.
Probably a lot of things. Listen to this cheeky breaky. Cheeky breaky.
Hello.
Yeah. Okay. That's a bit detached.
The definition of eternity.
Du vet at hvis du faktisk deliter noen av de greiene vi sier new på hele tiden, så kan det hende at det...
Ja, men under runtime, i while-loopen lager jeg ikke ny.
So,
Yeah, okay.
just to mention one, it's not visible here. But we talked about this before, radiosity in the
release mode.
Sorry? No. So in order to emulate shadows, not explicitly, so not really by using the modeling the effective illumination for a particular for an incident light for on a particular surface. One of the approaches to use the idea of indirect light is basically just to see to basically penetrate some sort of seeing with light and modeling how far surfaces absorb the light, and that gives a perception of shadows, but it's actually not a really and color bleeding. So basically, the idea having the idea of reflecting light over a given surface and feeding this light information from that reflecting surface onto the next surface. But it's not really a real shadow mechanism, but it can approximate shadow effects. That's the idea there. So we mostly work based on indirect light here, as opposed to the other approaches that work pretty much exclusively on direct light and just count the number of obscuring objects. So it's kind of an additive approach, whereas this one is different in its approach there again. And it's, I think, hang on, yeah, it's also considered amongst the object-based approaches because it needs to have some a model objects to bounce light off from, right? So you need to have color information, you need to have geometric information in order to apply this radiosity effect, where you're basically modeling the reflection of light rays bouncing off particular objects and carrying over some of their light information and color information onto the next surface. That's the key idea. Anyway, so that's brief talk about shadowing. Yes, any comments on your part?
Did you find all these resources yourself?
No. I took it from another lecture. There's a bunch of different lectures on color information. No. Well, I'm not working in this area, so I just wanted to give an overview that it's not like, for example, in the context of reflection or lighting, there's the model, the base model. That's the Phong model, right? So that is used for everything. If you start off with some sort of reflection effect, right? So, but in shadowing, it's not as clear cut. There's a number of competing algorithms that are used, you know. So, because the Phong model is quite generic in that the only assumption that it really makes is that you have an opaque surface, right? So you don't have transmission effects of light. But even though the Blinn model is the base model that's quite simple, it assumes an even surface, a plane surface. And that's a very strong assumption, which you know holds in many cases, but it's not as generically applicable as the Phong model. So you can't just say, well, you know, just apply that shadowing mechanism, you'll be fine, right? So that makes it a bit harder to use, and that's why the breadth and richness of the different approaches. Like you said, it's just approximations of real. Sorry.
It's funny because the cube doesn't have any lighting on itself. It's just a floor. Like, it's illuminated. The side of the cube.
Nice. Side of the cube, yeah.
It's illuminated even though it's in the shadow.
Oh yeah, that's right.
There's no shadow on the cube.
That's right.
Just
yeah,
cast.
that's a good point. Yeah, it's fine. So coming back to the hack idea, the Blinn model is an absolute hack. It's full of artifacts in that respect because it doesn't consider any geometric properties other than the boundaries or the meeting points, the intersection of the incident light and the object boundaries from a light perspective. Yes. But it doesn't change any sort of light information or shadow information on the object itself. Yeah. That's why it's so simple. But it's very cheap to calculate. But again, the assumption is very hard that you have shadow. And sometimes, I think here it's not as bad, but in some examples you see that you find that the shadows look very artificial on that basis because they're just like black blobs circling around a particular object, but actually the object itself doesn't change anything with respect. So if the lighting changes, the object won't change its illumination level. So that's can be a bit confusing in that respect. Yeah. stencil buffer. Yeah, cool. So, yeah, please.
Could you
Multiple
use the stencil buffer to have like multiple cameras? Like you have, if you have out of the actual player view, you want something to play out and you want the player to see it like on the screen in game. That you use the stencil buffer to put it on the screen.
I understand what you mean.
I think you can use it to save performance, because if you have multiple cameras,
Yeah, I'm just thinking because the depth, so it's basically operating on the depth buffer, right? And the depth buffer is operating from a eye perspective, from a camera perspective. So if you assume the camera perspective, then you can use it. But what you want to do is the multi-camera setup, right? Where you want to actually apply. You have a particular camera position, right? That's looking at the scene, and but you want to apply it from a second perspective, right? And use the stencil,
for example, or like a mini map that you have a camera from above.
Yeah.
Så
you use it to, so you don't have to render pixels twice. You say in the first draw call, you say, don't draw this part, because I'm going to draw a minimap here later. Or
Okay. Is that what you mean?
I think.
Are you meaning you want to limit? Do you want to?
For example, you can have
picture effects, or is that what you're thinking about? Or
yeah.
Because what Jonas' intuition that Jonas said makes quite sense. So his idea was to say, well, you could have modeled the entire scene, like say 3D Pac-Man, right? But one of the requirements is to have the minimap as well, right? So you could just not draw one part of the 3D scene and just instead project the minimap on this area, right?
Yeah,
is
you
that
could
the
use
kind
it
of
like
function?
that.
Yes.
Yeah.
So yeah, that would be a very nice application.
Or other UI elements.
Oh yeah, exactly. Anything
Because
seemingly
those
static
are
or
not
something.
in the same place. So
Yep.
you don't have to change the stencil buffer either. You can just
Not draw them, what?
yeah, you just don't draw things that are behind the UI.
Yeah.
Just use
Yeah.
this.
That's right. Especially if it's non-moving, right? The UI elements, then it's quite straightforward to model this one. Yeah, that's right. But let's assume you have the moving UI elements, then it would be an interesting idea to use the stencil buffer to filter the output. That's a good idea, actually. Yes. But I'm not sure about the second perspective. I'm just wondering if you actually have using it in this particular context. You apply a second camera perspective, apply a stencil buffer to that one. But you could emulate the effect, right? You could have a yeah, you instantiate a second buffer that basically just operates on the second camera scene. I don't know. I don't know. I'm not aware of the this application, but it's an interesting idea. But the minimap approach is quite interesting for that purpose.
So how would you go about having like a minimap using a second camera? Because the player view is has a perspective, but a minimap is just like what's called orthographic.
Yeah, projection.
Projection.
Yeah. So from on top projection, that's right.
Just have a different matrix for the orthography. It's
Yes.
It's
So
a
you
functioning
so you
camera.
have like two projection matrices
Yeah.
Yes.
Yeah.
and
one
two
perspective.
and two view matrices.
Yeah, so one perspective matrix and one orthographic matrix. The perspective is the normal.
Yes,
Yeah.
right. You simply apply different transformations onto the same.
The same scene.
Yes, onto the same scene. That's right.
And then you have two
Yeah.
different view matrices as well.
Yeah.
Yeah.
One
You
for
place the camera.
the
Yeah.
camera
Facing down.
facing down and one for the player.
Yeah.
Yeah.
And then also two
So you just have a
different
camera.
model
The camera
matrices as
owns-
well.
Hmm?
Different model matrices as well.
Yeah.
Because you need to transform it to top right of the screen statically instead of
Okay,
based
that's
on-
the view. But But the camera owns its own matrices, I think. It should own it. You put the perspective and the view matrix inside the camera if you have a struct. So you can have many cameras.
So you have a camera struct or a class or whatever with its own matrices.
Which you instantiate. And you can
So you call one camera, player camera, and one camera, minimap camera.
yeah.
So, but I'm still, you have two cameras, I see that, but then you need to decide how to draw them, right? In the screen output. So how do you do that?
Yeah. Two draw calls.
Two draw calls, yes. Sounds very wasteful though.
Then you can use the stencil.
Then you can use a stencil buffer, that's right.
Yeah.
It sounds like a reasonable approach, I guess.
But two draw calls is too much.
Isn't multiple cameras wasteful?
Yeah.
Yes.
It's one, you have to render the geometry twice.
You do everything twice, that's right, yes. I'm just thinking, what would be alternative for your problem?
Most minimaps are simplified.
Yeah. Yeah, you
Probably like 2D textures,
pre-bake
which you base on your 3D
Yeah,
position.
that's probably the easiest one. Just make a texture and just have some sort of the position indication on the texture. That's probably the cheaper way. Yeah.
But then you can also do stuff. You can also mark things. You can generate the texture, so you can add the markers to the texture.
Yeah.
So you can append different things and create a multi-layer texture that you then move around.
Okay.
So you generate that at startup.
If you have dynamically created maps or random generated maps, you would have to
use the
generate textures during runtime for it.
Take the map as input into the geometry shader.
Sorry?
You can take the map as input for the geometry shader. So you generate the world based on the minimap? Yeah.
That's cool.
That's so procedural generation.
That'd be cool.
So basically the complete opposite of what we're thinking.
Yeah, we're thinking something and then you turn it upside down.
So you can just concentrate all the map drawing in doing the geometry shader and do all the rest in
I think that would be possible, yeah.
vertex shader.
You could even
That's a
generate
good idea.
the terrain based on like the alpha value or something. You don't even have to use the alpha value, but you can have it there. And you can define the height of the terrain, for example, with the alpha value of the texture, so you can have textures. The texture that is generated is first generated with like Perlin noise or something, and then afterwards you generate like road maps or something on top of that randomly. And,
why use maps when you can use textures for everything?
Yeah, and then you generate the world afterwards based on all of this information and render it in 3D and just conveniently show the minimap in the corner.
That's called a height map.
Yeah, but use the minimap as a height map for the generation of the world.
You can bake the height map into the texture because it's only one value per each pixel.
Yeah, exactly. And that can be the alpha value because you're probably not going to be using it anyways.
Since it's a minimap,
yes.
it won't be
Transparent terrain.
Yeah, because that's going to be oh my god. What?
Well, that's good for the 3D chess people. That who may need transfer. If you plan to do that from
on the minimum.
Not some rain.
Sorry?
They should probably not use the terrain map
because it would be using textures.
No. Maybe about maybe having an environment around the chessboard, like just to have a background or something, and that should probably be the terrain.
or just the texture.
Ja. Så alle 4 fargene
kan bli bortfarget.
Til forskjellige ting.
Hva type det for noe? Det vann? Det liksom... Oh my god, you could define the material of the surface with the RGB values?
You split all
all the 250
into individual bits so that you can have like a bunch of individual bools for every pixel, and you store that in your color.
So the alpha component could be the height, and then, for example, the R component could be the material types. You could have 255 materials, and then you could use green and blue for something as well.
Because you aren't going to use the colors anyway, because you're going to put textures on it. So.
Yeah,
you want to use normal.
It's time to start.
Yeah, that's cool. That's a good idea. Like, how much information can you bake into an image and then generate the world from it?
It's quite a lot if you just compress it as much as possible.
Yeah.
There is a lot of information in it.
You want to take very much
just hide stuff in images.
before you don't want to bake in information which you have to decide on during that. You just want to bake values. Like here's the value, I can multiply it, can be different. But once you have to say if this is bigger than
Yes. Okay, thanks.
Okay, thanks.
so for example flags.
I threw it on the ground.
Weird.
Fuck the shit.
Flag. You could use it to.
Så du har fått fortelle meg at jeg kan skrive
Stikker vi der
Yeah, just that test is that.
Spaserer på
And we're not going
allerede.
That's the idea. Right? So
It's
it's baked into the GPU, so it's more efficient, right? So, however, it's
Det kommer godt i gang da, men
but what is emulated is sensor buffer, right? So, right one configures itself.
let's get like
det noen dere tar lengre skritt enn andre.
to not have an if statement or background changes. Change the color. It's more
what we have the same part.
I need to walk. It didn't say if, that's the point.
You're old enough to walk, you're old enough to walk it off.
A value was higher than 0.8 in red. Challenge.
Right.
I'm not going on this.
Yeah. The clown function is exactly as the if else in Unity. But not in the shaded language.
Når du driver og sender testmeldinger, men du vil ikke bare ha random bullshit, så du sitter og har en samtale med deg selv.